Andy Bernard. Andy Bernard! I'm not gonna explain what I mean by that, so I might just cut that part out entirely. Boom! Good morning, good afternoon, good evening, good night, good whatever time it is where you are. Doing something a little different today. I find myself with some extra time, so I'm here, beautiful day at the lake, and I want to do some math. I'm ready to do some math. So, we did some target round questions the other day, math counts, and I think we should do some more. So last time we did the second question on the first pair of questions. Remember, the target round comes in 4 parts. You've got 6 minutes to answer 2 questions, and then that happens 4 times. Target round, you can use the calculator, but many of the questions should be answerable without it. Not necessarily all of them, though. What's another good one here? Maybe number 6? I mean, we could definitely do 5 really quickly. Should we look at number 5? In how many different ways can 4 students stand in a straight line if 2 of the students refuse to stand next to each other? What's the deal, guys? Why would you refuse to stand next to each other? So this is a permutations and combinations question. Permutations and combinations are about the number of different ways to arrange elements. They often end up involving factorials. There are permutations and combinations buttons in your calculators, or functions in your calculators anyway, although of course you have to know where to find them. But again, what if I was just jotting this down really quickly? So we've got 4 spaces, right? 1, 2, 3, 4. And let's give the students names. Let's call them A, B, C, and D, alpha, beta, gamma, and delta. Andy Bernard. Andy Bernard! I didn't even do... is that how they named him? Andy, Bernard, Carl, and Dale. And let's just say that Andy and Bernard have a problem with each other. Andy and Bernard do not want to be next to each other. One thing we could do here is we could literally just list out every single one of the 24 possibilities for how they could stand, and then cross off all the ones where Andy and Bernard are next to each other. Oh my gosh, just happened. That's amazing. Okay, so this is what the list would look like if we gave our 24 individuals all the possible spaces. That is what would be called 4 permute 4. And so in your calculator, this would be 4p4, or sometimes it's called NPR, 4, 4, or I suppose it could even be something like p 4, 4. But the basic idea is that if I have 4 spaces, again, 1, 2, 3, 4, any of the 4 people could go first, and then of course 3, 2, and 1 are left over. And what we want to do is multiply all those possibilities together. And so that's why our list right now has 24 possibilities. Now again, what we're trying to do is to make sure that Andy and Bernard don't end up next to each other. And so you can see I have crossed off here any scenario where Andy and Bernard are actually next to each other. And if you want to see, you can see, okay, A and B next to each other, A and B next to each other. Same thing, but a different order. They didn't say, oh, as long as he's to his right, it's okay, or if he's to his left, that's a problem. They're next to each other, it's a problem. And again, you have 6 minutes for the pair of questions, and you have roughly 3 minutes for any given question. So probably you could list this out and cross this stuff off in 3 minutes. But this is a number 5. Number 6 should be getting relatively tough. What if I need a little extra time? Yeah, what if I don't want to sit here and list this stuff out and I want to be able to get this question right? I think in this particular case, this is a good example where complementary counting ends up being really helpful. So if we know that there are going to be 4 factorial ways, so again, that's another way to think about what's happening here. There are going to be 4 factorial arrangements of these 4 people. It's a little bit tough to start to think through, well, when are they not next to each other? When are they not next to each other?
How am I not myself?
When are they not next to each other?
Myself.
How am I not myself?
How am I not myself?
When are they not next to each other? Yeah, like when do they avoid each other? Because if, for example, Andy goes first, well, then we know Bernard just has to avoid slot 2, but he could be in either slot 3 or slot 4. And so in that case, he has 2 places he could end up going. But if, on the other hand, Andy went second in this list, well, all of a sudden that becomes very limiting for Bernard. He's not going to go first or third. He's only going to be able to go to slot 4. So we could consider it this way by kind of splitting up, well, what if Andy goes first or last? That's one scenario. What if he goes second or third? That's a different scenario. And we could actually use some symmetry arguments to try and figure that out. But I think it's a little bit easier to just think, what if they are together? Because then essentially what we're saying is, all right, we really only have 3 elements. We have the Andy-Bernard pair where they are together. If we can figure out all the times that they do sit next to each other, whatever that number is, we can just subtract that from what we know to be the 24 actual possibilities, and that would give us the number of times that they're not next to each other. So this is what I mean by complementary counting. Sometimes it's much easier to find the opposite of what they're asking about and then subtract that from the total. If we do this, we can treat A and B like its own element, and then of course you would have the element for Carl and the element for Dale, and really it's just 3 elements that we're looking at. So what happens here? How many possibilities are there? If I'm just arranging 3 elements, 1, 2, 3, well then there would be 3 factorial ways to make that happen, and that means that we've got 6 different ways that A and B could be next to each other. But you do want to notice that's 6 different ways with the order A, B. If this is the order B, A instead, and then you're placing C and D somewhere else in this line, that's going to be another 6 ways that they could be next to each other. And so we end up with a total of 6 plus 6 is 12 different ways that they could be next to each other. In this case, because it was 24 total ways that they could be arranged, we do 24 minus 12, and that gives us finally 12 ways that A and B can be seated and not be next to each other. If you come back over here to our list of all the outcomes, that's exactly what we see, right? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different ways that A and B are not next to each other. Pretty classic permutations, combinations style question where we're deciding how to arrange items. A combination style question would be more like deciding how many groups of elements are possible. We're given a restriction here that we have to obey, and so that's kind of the wrinkle that makes it a little bit more complicated than simply 4 times 3 times 2 times 1, and then that's our answer. But it's a restriction that's straightforward enough we could figure it out. Additional challenge to you, following the same reasoning that I went through with complementary counting, what if there had been 5 people, and again 2 of them do not want to sit next to each other? How many arrangements are possible when you have 5 people with 2 who don't want to sit next to each other? Can we figure this out in general for n people with 2 who do not want to sit next to each other? Extra challenge, can we figure this out in general for n people, k of whom don't want to sit next to each other? So let's say we had 5 people and 3 didn't want to sit next to each other, or 11 people and 7 didn't want to sit next to each other. Is that even possible? We might find that some of those outcomes are impossible. But play with that, see what you come up with. I hope that has been helpful. I hope you have enjoyed our lovely afternoon at the lake, and I will see y'all around.